Okay, today what we're going to do is we're going to move on to section 8.3. What we're working on is we're talking about how to conduct a t-test for finding the mean when the population standard deviation is unknown. So just like section 7.3 when we did the confidence intervals, okay, same idea. We're going to be using the t-test because we don't know sigma, okay, which means we do know S, our sample standard deviation. That's the only one we know. So differences from section 8.2, what we just did. We had learned to do averages when we, like a test for averages when we knew sigma, our population standard deviation. Our formula is going to use S here instead of sigma, okay? We're going to have degrees of freedom as n minus 1, okay? Since we don't know the population standard deviation and we only know the sample standard deviation, then we have to use the t-chart or TCDF in the calculator to get the p-value. And when we do TCDF, it's going to use degrees of freedom as n minus 1. Now we'll model that in a few minutes in the calculator, okay? Similarities. Step 1 in the hypothesis test, our hypotheses are still the same. Mu equals, and then mu is greater than, or less than, or not equal to. Our decision-making process is still the same. We're going to compare p-value and alpha. And we're still going to make the same idea, like sentence, for our summaries and our conclusions. All right, so if we've got example 1, a job placement director claims that the average starting salary for part-time nurses is $24,000. A sample of 10 part-time nurses' salaries has a mean of $23,450 and a standard deviation of 400. Note, it doesn't say population standard deviation, and this standard deviation of 400 is in the same sentence as the sample of 10. So the sample of 10 nurses have a mean of 23,000, and a sample of 10 nurses has a standard deviation of 400, which means it's a sample standard deviation. So I wrote that down over here, S equals 400. All right, we want to know, is there enough evidence to support the director's claim? So as we look at this, it's just saying equal, not equal, right? He's just claiming it is 24,000, so we're saying, is it equal to? And since there's no buzzword, greater, less, increase, decrease, more, none of those words exist, so it's just going to be an equal, not equal. We're going to plug it in the formula. It's the same exact idea as what we had just done, okay? It's sample mean minus population mean, or the hypothesized mean, over standard deviation over the square root of 10. Okay, we get negative 4.35. This is going to be a two-tailed test because it's equal, not equal. All right, and I've got the steps for the p-value, like the information for our p-value here. So just like with confidence intervals, we have degrees of freedom. Right, when we had confidence intervals and we need to use a t-chart, we had degrees of freedom, and it would be n minus 1. So 10 minus 1 would give us 9. In the calculator, what we're going to do is we're going to go menu, number 6, stats, number 5, distributions, and then it's going to be right here, number 5, TCDF. Okay, for this problem, if we got negative 4.35 for our formula answer here, then we're going to find this p-value. So the lower bound is where your shading starts, negative infinity, which that's the default. Our upper bound is where the shading stops, negative 4.35. Make sure you type in the correct degrees of freedom, 9. And it gives us this as our p-value. Now be careful. This is not 9.25. This is e to the negative 4, which is times 10 to the negative 4, which means then you would move it 1, 2, 3 spots to the left. So I got 0.000925. And the reason why I expanded this, A, it's a small one to expand, and B, you need to double it. And doubling in scientific notation is tricky. We need to double it because it's a two-tailed test, just like we've been working on with all the other types of problems for two-tailed tests. So when you double this, you get a p-value of 0.00185. Okay? If you have p-value smaller than the alpha, then that means you reject the null hypothesis, which means that we can conclude that the average starting salary is not 24,000. If we're rejecting the null, then that means we have enough evidence to conclude that this is true. All right, so again, I hope you wrote down the steps. I'll model it again for TCDF for the next problem. Okay. An educator claims that the average salary of a substitute teacher in districts in Sugar Land, Texas is less than $60 a day. A sample of 8 districts is investigated or sampled, and a mean of 58.88 and a standard deviation of 5.08 is found. Is there enough evidence to support the educator's claim at 10% significance? 10% significance is another way of saying alpha equals 0.10. All right, so you jot down your information, right? N, X bar, S. If we're saying it's less than $60 a day, then we're going to have mu is equal to 60, mu is less than 60. We're going to plug it in our information, sample mean minus hypothesized mean over standard deviation over root 8. We get negative 0.62. Okay, it's a less than, which means it's a left-tailed test. Okay, so try your calculator right now. All right, you're going to go menu, stats, distributions, and then number 5, TCDF. Our lower bound is negative infinity, which is already there. Our upper bound is negative 0.62. Our degrees of freedom should be 7, right? If we have n minus 1, if n is 8, degrees of freedom 7. And I get my p-value to be 0.2774. All right, I'm not doubling it because it's not a two-tailed test. So I get, do not reject the null hypothesis because my p-value is greater than alpha. If I'm not rejecting it, that means we can't agree with this. So we do not have enough evidence to determine that the average salary is less than $60. Even though the sample we collected was less than 60, it wasn't far enough below 60 to be mathematically conclusive. Okay, it could just be a coincidence that it's just a tiny bit lower, but it's not far enough below 60 to definitively count as less than 60. All right, so what I'd like you guys to do right now is I'd like you to try number 3. Set it up. All right, at this point you should be good and cruising. Okay, so as we set this up, we've got physician claims that joggers' maximal oxygen uptake or intake is greater than the average of all adults. Sample of 15 joggers has this is the mean and a standard deviation of 6. If the average of all adults is 36.7, is there enough evidence to support the claim so that the joggers are greater than your average adult? So go ahead, do the entire problem. Do it in pencil if you need. Pause the video and then come back and check your work. Okay, hypotheses, formula answer. Here's your test statistic, 2.52. Remember, this is lower bound, upper bound, degrees of freedom. So it's where the shading starts, where the shading stops. Starts, stops. This gives us a p-value of 0.0123, which means we reject the null, okay, because it's less than your alpha. Make sure you always show this comparison. So now we know that the average jogger's uptake is greater than, oxygen uptake, sorry, is greater than 36.7. You could say we have enough evidence to conclude that the average jogger's oxygen uptake is greater than 36.7. All right, so now if you take a look at number 4, okay, we've got a survey of 15 large U.S. cities find that the average commute time one way is 25.4 minutes. The Chamber of Commerce executive feels that the commute in his city is less and wants to publicize this. He randomly selects 25 commuters and finds the average is 22.1 minutes with a standard deviation of 5.3 minutes. At alpha equals 0.10, is he correct? Just remember, guys, too, whatever the font is, you know, for whatever the document or the website or whatever, sometimes alpha can look a little different. This one's like shrunk this way. Sometimes it's real long. Sometimes it's shorter. Okay, sometimes it's like if it's in italics or something or whatever the program is, sometimes it's a little harder to see these parts. Alpha can look a little different depending on what font was used. So I had written down here that this is your extra info. Okay, and I meant to write it after, so I apologize. But the reason why this is extra info is this isn't the sample that this guy uses. This guy is talking about his city from his population, and it's 25 commuters from his city. This 25 is our N. This 15 is just a different survey. Okay, it's not the one that the man completes for his city. So again, pause the video, go through, check it all out, all right? Practice all these, like do this problem, okay? And then when you unpause, we should have this guy as our answer, okay? N is 25, sample mean, standard deviation, alpha. We have less because he thinks he has a shorter commute. So we had negative 3.11 for our formula answer. Here's our shading because it's a left-tailed test. TCDF with this information, degrees of freedom is 24, gives us here. So we have our p-value is less than alpha. We're going to reject the null, which means we have enough evidence to conclude that the average commute in the city is less than 25.4 minutes. Okay. You will see down here for the homework whenever we get to these problems that I made a note. So make sure that whenever we do these assigned problems that you come back and you look at this. All right, for number 12, you need to make sure we practice this a million times. Okay, but if you're going to be given a data set, so you need to put your data set in a list. You need to get your mean and your sample standard deviation from your one variable statistics so that you can move forward. All right, good job. I hope you took very thorough notes today, and I will see you soon.